All right, so welcome to our CSEC Physics Crash Course 2022. This is session 8, the last session where we'll be looking at past paper questions that are relevant to the topics to be sent. And as usual, we have myself and Ms. Rose as presenters. Now, the topics that you were given are listed here. So we have about 15 or so topics from which the exam questions will be set. And we have prepared some answers to questions that are under these topics. We'll not necessarily go in the same order here, but we will do at least 2 questions, I think, from each of these areas. So we have graphs and data analysis, vectors, forces, Newton's laws, hydrostatics, temperature, gas laws, wave motion, sound, lenses, current, electricity. We have electrical quantities, circuit diagrams, radioactive decay, half-life, and nuclear energy. Right, so those are the topics, the questions and paper to will come for this year. All right, so the first question that we look at is actually a data analysis question. So the first question on the paper two will be a data analysis. And this one comes from the topic of hydrostatics. So we'll be looking at hydrostatics and the data analysis together with this question here. So most times it's, or in fact all times it's question on that's an experimental based question. All right, so we have a diagram here of experimental setup where a student measured the pressure of a liquid at different depths. And the values are given in this table. Now, also, you will plot a graph for this question. And the graph question says plot the graph of delta P against delta H. That's changing pressure against changing height or depth. So the values are given here. Once the question says, once you're told that you're to plot a certain quantity against another one, right? The one that comes first will be the one that you put on the y-axis. So this statement means that you're to plot change in pressure on the y-axis and then the change in height on the x-axis. Right, so we're going to look at that graph, but let's see this question here. Says write an equation linking liquid pressure, density, and depth. Now, the formula for liquid pressure or fluid pressure will be equal to rho times g times the change in height or depth. And the rho here is the density of the fluid, whether it's a liquid or a gas. G is the gravitational field strength, which we normally call we just say gravity. All right, so when you are calculating the pressure in a liquid or a gas, right, fluid, you can use, or you will use this equation. All right, pressure is equal to density of the fluid times the gravitational field strength times the height or the depth. Right, so let's look at the graph. All right, so you're going to have your change in pressure values on the y-axis, that's the vertical axis, and the change in depth on your x-axis. Now with this question, they have already marked the x-axis with the scale. And for the y-axis, you need to choose a suitable scale. And you want to make sure that you use up most of the graph paper. So I think the best scale to use here would be 1 centimeter equal 500 pascals. So we are going up by 2 centimeters here. So every 2 centimeters will increase by 1000 pascals if the scale is 1 to 500. You don't want to make the graph too small where the line doesn't cover at least 2/3 of the graph paper. All right. So the scale here is 1 centimeter equal 500 pascals. But you have to remember that 1 centimeter is from here to here. Every 5 divisions is equal to 1 centimeter. You do not have to label every 1 centimeter. You can label every 2 centimeters. So based on the values, by now, everybody should be able to plot or find the coordinates of the data points. So we have these points, and of course, they seem to form a line, a straight line. So we're going to draw our line of best fit. And remember that the line of best fit, it's not going to pass through all the points. And in fact, it doesn't have to touch any of the points. But what it should do is to give you an even scatter of the points. Right? So the line should be drawn in such a way that on either side, you have an equal scatter of the points. So you would line up your ruler along the points and ensure that the edge of the ruler is going to give you a line that has equal scatter on both sides. So you do not rush to draw your line of best fit. Right? You're going to line up your ruler, make sure you can view the points. And this is why we need a transparent ruler to do the question on graphs. So as long as you have your ruler aligned in the correct position, then you can draw your line. You don't want to have to draw your line and then erase it and draw back over another line. So line up the ruler as best as possible in the same position as the best fit line before you draw any line at all. You should have a title for your graph. Simple title will just say what the graph is showing. You will write out the words here for the variables. So graph of change in pressure against change in depth. And for the labeling of the axes, you will put your symbols. Right? No need to write out the words here because you have stated that in the title. Right? So the title will have the words for the variables, and the axes you can use just the symbols. Symbols for the quantities or the variables, as well as symbols for the unit. You must always put your unit. So the example, the filling in that they did for you here, you'd see that they have delta H slash M telling you that the change in depth is in meters, right? So from this, you can know that you should have a similar labeling here. Now, after you draw your line of best fit, you will be required to find the gradient, and persons should by now know how to find the gradient. You're going to choose two places on the line and mark them off. Then you use a broken line to trace where those points match the axes. Right? So the corresponding x and y values for your first point would be, say, here and here. Let's use some annotations. So you're going to have a point here that you would have chosen. And I'm just sketching so that you can have an idea. So you would not really put such a large mark on your graph. You have a point here. And where this point is lined up with the y-axis, that would be your y2 value, and the corresponding x2 value. We're going to have y2 here, and x2 here, and then y1 here, and x1 here. And you use these values in your formula or your equation to find the gradient. Now, the next question says, that they have given the densities of 3 liquids, and you are to find or tell which of these liquids were used in the experiment. So what we have now is that the graph is give us a straight line, and we know that the equation of a straight line y is equal to mx plus c. The intercept in this case is 0. So y is equal to m times x, and since pressure is equal to rho gh, right, then we know that we are knowledgeable that we have plotted delta P on the y-axis, right, and we have plotted delta H on the x-axis. It therefore means that the gradient would be rho times g, right? So the slope or the gradient of the graph corresponds to rho g, and if we know g, then we can find rho, right? So the gravitational field strength was given or is given here as 10 newtons per kilogram. So we know that the gradient was 9,800 pascals per meter, and therefore the density would be equal to 9,800 divided by 10, and that is 980 kilogram per cubic meter. Now, the closest value given in the table would be 1,000. You would not put it at 800. Right? 980 is, sorry, 1,000 is closer to 980 than 800 is, right? So your answer would be water. The liquid that was used would have been water. Next question. Just get this a bit easier. Right, so next question says, using the graph you plotted on page 3, find the total pressure exerted on the base of the container. Right. Now, the total pressure, we have to include atmospheric pressure because the container was open to the atmosphere. Right. So if we look back at the question. So the liquid was in an open container. The total height, well, the height of the liquid was 0.75 meters. And so if we use that in the equation, we have, sorry. So we have rho GH plus the atmospheric pressure. Rho GH is, that's a gradient of the graph times 0.75 meters. That would give us the liquid pressure, because you have to remember now that what we were plotting on the graph would be the change in pressure. Right? Change in pressure against the change in height. So the gradient has to be multiplied by the height of the liquid to give us the actual pressure. So that's the liquid pressure now. But at the base of the liquid, the atmosphere is also acting, or from you move from the surface of the liquid, the atmospheric pressure will be exerted as well as the liquid pressure. So we have to add those, and we get a total of 110 if we are using, say, two significant figures, right? 110,000 pascals. Right? Are there any queries so far? So atmospheric, okay, atmospheric pressure was given as well. So when you're doing these questions, please, that's why we also encourage persons to read through the question first before you actually do it. Because sometimes persons will say that they did not see the values that were given, and then they actually left out the question or not do part of the question. So you have to make sure, right? Because the values given here are somehow used, right? At some point in the question, you have to use these values. So make sure you look through the paper, because these values will be given most times at the end of the question. They won't put it, generally, they won't put it up here. They put it at the end of the question. So make sure you look, right? Make sure you read through all of the questions. All right, next part of the question. And this is a long question because it's data analysis. So it's the longest question on the paper. All right, so you are given a diagram with a manometer, and it's measuring the pressure of our gas. So here we are asked to give our state and give a reason if the pressure of the gas is less than or greater than atmospheric pressure. So we look at a manometer. This is a U-tube manometer. So it has two arms, and we have mercury as the liquid inside. So if the gas pressure is greater than the atmospheric pressure, right, then the liquid level will be will be lower than the liquid level on the other side, right? So remember, pressure here exerted here will be the gas pressure, while the pressure on here will be the atmospheric pressure. So for the gas pressure to be above the atmospheric pressure, then the liquid level on this side of the U-tube manometer that is connected to the gas supply, right, that liquid level will have to be lower than the liquid level at the other side, on the other side. So the pressure of the gas here is less than atmospheric pressure, right? Because now what you also need to know is that at the same level, right, the pressures would be the same, right? So at the 10 here, whatever pressure is exerted here will also be the pressure here at the same level. Right? So that means the atmospheric pressure is greater than the gas pressure. So the reason you give the fluid with a greater pressure pushes the mercury column further down, right? So the atmospheric pressure pushes the mercury further than the gas itself, and so it is less. All right, calculate the excess pressure in millimeters of mercury. All right, millimeters of mercury is a unit that is probably archaic, but it's still used in some cases. All right, and the standard atmospheric pressure is about 760 millimeters of mercury. What this means is that if you have a mercury barometer and it's open and it's encountering normal atmospheric pressure, which is about the pressure at sea level, it will rise, the mercury will rise to a height of 760 millimeters, right, in the mercury barometer. So we use that as a standard pressure if we're talking about millimeters of mercury. So the difference in height of the column in the two arms indicates where the difference in pressure is. All right. So we can use atmospheric pressure and subtract from that the pressure of the mercury. All right. And we have 760 millimeters of mercury for the atmospheric pressure. And for the pressure of the mercury, that would be 250 minus 10. Let's look back at the diagram. Right, so we have this here. I think that should be, this is centimeters or millimeters, so 250 minus 10, this is 10 centimeters, would be 100. So this should be 100 actually, not 10. So 760 minus 150, 250 minus 100 is 150. Right? So the excess pressure is 610 millimeters of mercury. Right? So pardon the error here, this should be 100 because it's millimeters, but the question shows the value in centimeters. Centimeters. Right? So roughly 250 here and 10 here. So this difference in height between the liquid levels, right, will give you the excess pressure. Okay, this question is about vectors. And it says, give the difference between a vector quantity and a scalar quantity. Now, a scalar quantity is one that has only magnitude, while a vector quantity has both magnitude and direction. Right? So very simple answer there. All right, complete table 2 by writing each of the physical quantities from the list below in the appropriate column. You are given mass, momentum, displacement, heat capacity, temperature, half-life, and upthrust. So you have to categorize them as either vectors or scalars. So what you do is to look for which one has to be described with direction in order to be properly described. Right? If you are not familiar with all vectors and so on. Right? So mass, there's no direction to mass, so it goes scalar. This one has been done for you. Momentum is a vector, so it's placed there. Right? So momentum, displacement, and upthrust are vectors. All of the others are scalars. Right? So you just have to remember that scalars just have magnitude. They don't have any direction at all when you're talking about scalars. Right? So scalars are not directionally aware. Can put it there. All right, so remember, we're just focusing on questions that are based on the topic. So you might see some questions that been answered. All right, define the term displacement. Displacement is the change in position of an object, or it is the distance traveled in a specific direction. Right? So must be directionally aware. Change in position. Once you talk about change in position, the direction comes in here. Right? So displacement is a vector. Acceleration is also a vector. All right, now this one will be explanatory because we cannot, or we could not do the question on the screen, right? So I explain what you need to do. All right, so you were given OA and OB as the two vectors. Right? Repeat mass velocity OA and the wing's velocity is OB. So what you are to do is to measure the length of OA, or OB, sorry, and you can use a protractor to measure the angle here. And then what you'll do is to make sure that you measure that same angle here. And then you're going to draw a line parallel to OB at this same angle here, whatever angle this is. And I have estimated it to be about 63 based on the software that I was using at the time. Yeah, about 63 degrees or so. So whatever it is, you would make your angle out here 63 as well. All right. Then you draw a line of the same length as OB here, because what you're doing is to complete the parallelogram. So you're applying the parallelogram law here by drawing or by completing the parallelogram, and then you draw a diagonal from O to C. Right? So you know, remember you were only given OA and OB. So the red line and the blue lines, right, were filled in to indicate how to do the question. So you would measure the length of OB and measure the angle between OA and OB. Make sure that angle is the same angle on the outside. Draw a line AC that is equal in length to OB. And then you join B to C. That completes the parallelogram. Then you measure the length, then you draw the diagonal from O to C. Measure the length of the diagonal. So OC is what the length you are going to get. And then you use the scale to convert that length to meters per second. Right? So you are given that 1 centimeter equals 2 meters per second. So if you get a line that is, let's say, 15 centimeters long, then you know that the magnitude of your vector would be 15 times 2, because every 1 centimeter equals 2 meters per second. Right? So whatever the length of the diagonal, because of the scale, you're going to multiply by 2 to get the magnitude. And then you use your protractor to measure the angle COA. Right? They specifically say that you are to state the direction in degrees from OA. So this from OA. So OC is how many degrees from OA. So this angle here. This angle here is what they want. Right? So you use your protractor. And make sure you know how to use your protractor. The protractor will be aligned somewhat like this. Just roughly speaking, where the 0 is here at O. 0 of the protractor. The center of the protractor, that is, at the base, is at O. And you measure. Make sure that the 0 of the protractor is running along OA, and you're going to measure the angle where this blue line is. In my case, I have a blue line here, right? So whatever angle this is would be the direction, right, from OA, right? So you are really given part of the question done. In other cases, you have to draw the parallelogram from scratch. So this one is partially done. So I don't have the answer for this, but if you carry it out accurately, you get the answer by multiplying the length of the diagonal by 2 to get the magnitude. That's 1 mark. And then measure using the protractor angle from OA. Right? So the angle that OC makes with OA, that gives you the direction. All right, this question. This question is a radioactivity question, also data analysis. Unfortunately, the question is not shown, but you were given values of activity values of activity and time. And you're to plot a graph of activity against time in days. Now the activity is given in disintegrations per second. And let's start with the title. So we're going to have a title. Graph showing the activity of a radioactive sample against time. Just a very simple title. You're going to have there. And you're going to, this time you are not given any axes drawn in for you or any labeling, so you have to figure it out. And I'm using a scale here of 1 centimeter equal 2 days on the x-axis, and 1 centimeter equal 2 disintegrations per second on the y-axis. And this scale is slightly awkward to use, but based on the values, it can be easily, or it can be read with not so much difficulty. But normally, we wouldn't use a scale like this. Right? So 1 to 2 is being used here. And we have how many points? We have 2, it's about 7 data points. And again, I must point out that you won't make your points so big. I just, because of, working on the screen, and the points, it's very difficult to make them small. But a rule that you can use not to make your points bigger than the smallest squares on the graph paper, right? So you want some small, neat points, you can make a dot with a circle around the dot, or a cross, but make sure they are small and neat, not too small, but probably as large as the smallest square on the graph paper. So you have your points. 40 corresponds to 0. And we have 30 corresponding to 4. Right? So we have our points, and they are not in a straight line. They don't seem to form a straight line. Whenever you see this, you can be certain that you will not draw a straight line if you look through the question and see if they ask you for a gradient. Once they do not ask you for a gradient, you know that you should not draw a straight line. Even though the points are aligned in such a way, right? But you may want to make sure, because sometimes the points are big, you know, based on errors in the experiment. The points can be scattered, but you are to look at the trend that the points show. If they show a curved trend, like in this case, and you can know based on the type of question, it's a radioactivity question, and radioactive decay occurs in an exponential manner, so you won't get a straight line with exponential decay. So you get a curve that slopes downwards, right? But if they really don't ask for a gradient and it's not exponential decay, like a radioactivity decay, you can be sure it's a curve. So we have a curve here, and you use your free hand to draw a smooth curve. And again, because of I'm not using a physical thing, then this might not be as smooth as it should look. All right, so we have our axes labeled T for time in days. You know, the graph is as large as it can be, taking up most of the graph paper. Activity in disintegrations per second, and the title, which you have all of those. The only thing missing from this graph is the read-off points. Now, the question here requires you to do some read-off. So it says you are to use the graph to calculate the average half-life of the sample, determined from the average of 2 or 3 values. All right. So 2 or 3 values, I'm using 2, right? So I use 40. Now at 40, that was the initial time. So time is 0 there. And you check for half. All right, how much time would have gone when the disintegration reaches half of the 40, or whatever number you started with. All right. So I chose 40 for my first one. So the next one would have been 20, and I look at the time. The time is 8 days. So the half-life, first half-life value would be 8 days, 8 minus 0. And then I chose 16, and at 16 it was 10.4 days. And then, so if I chose 16, then half of 16, I'd have to go to 8 and look at the time that it takes, or the time at which it was 8 disintegrations per second. And that was 18 days, and that time difference is about 7.6 days. So that's my second half-life value. Now my average half-life would be the 2 half-life values divided, the total of the 2 half-life values divided by 2, and 7.8, but you round it up to 8 days, right? So, you know, based on how the graph is drawn, you'd probably get something similar, but each, 8 days is the half-life, yeah, average half-life. Right, so when you're given a question like this, you definitely on the graph, you need to show your read-off values. Mine is not there. All right, but you'd show your read-off values. For example, if I was showing mine, I would have at 16. Use a broken line, of course. I don't know, there are no broken lines in this software here. So I just illustrate 16 and read off here, so it's that, and I look for 8, and I will draw the line to meet my broken line to meet the graph line around there, and then I draw a broken line again to meet the x-axis, so it's about there, and I take my readings, right? So you do that to show how you got your values. All right, so the half-life for that is about 8 days. Next question, no. Use the graph to determine the activity of the sample after 25 days. And so if you go back to the graph, after 25 days, we would have, so we make another readout. So we look for 25 days. And the scale is 1 to 2. So here will be 26. So 25 would be halfway between here and here. That is 2.5 lines out there. And we use a broken line and another broken line going across from there to meet the y-axis. Of course, make sure you use a ruler. I've seen a number of times where students are asked to draw lines and they don't use a ruler. That is not acceptable. Please use a ruler. Only if the graph line is a curve, you don't use a ruler there, but for everything else, once you join a straight line, make sure you use a ruler. All right, so we're looking at 25 days. After 25 days, disintegrations per second will be about, so this is 4, here would be 6, right? 6, so that means this is about 5 or very close to 5. So the question was done also on physically, so I would have known that answer there. So the answer is based on the physically done graph. So 4.6, very close to 5. Right? 4.6 disintegrations per second. Next part of the questions is state 2 types of radioactive emissions. And there are 3, so any 2. You have alpha particles and beta particles. And then you have gamma radiation. So any 2 of the 3 will give you those 2 marks. And then they ask which type of radioactive emission is the most dangerous to human tissue. And of course, that will be gamma rays or gamma radiation. And they don't ask you for a reason here, but the reason would be because gamma radiation consists of waves of very short wavelength, which can penetrate through your skin and even impact your genes or your DNA and damage them, right? So it can, because it's so penetrating, right? Then it can cause serious damage. You weren't asked for a reason, but it's good to have an idea, because if you do not know which one, if you don't know why, then you may not be able to answer the question. All right, this one is electrical question. What is meant by electrical resistance? Now, electrical resistance would be the opposition to the flow of electric charges or flow of electric current. 1 mark. You do not necessarily have to state how it is calculated. You could also say it is a ratio. It's the ratio of the potential difference to the current. Right? Next part of the question. This one speaks about ammeters and voltmeters, how they should be connected, what's the resistance, what the resistance should be, that is, and the reason for the resistance. So ammeters are connected in series, voltmeters are connected in parallel, and because the ammeters are connected in series, the resistance should be very low. Now, you know that in a series circuit, the total resistance or the combined resistance increases with each component that is added. So that means if the ammeter should have any sufficient amount of resistance, it is going to add to the total resistance in the circuit and decrease the current that is flowing. The ammeter should not impede the current flow, it should only measure the current. Right? So that is why you want the resistance of the ammeter to be low. And for the voltmeter, because it is connected in parallel, we know that when we connect a component in parallel, if it has any sufficient, if it have any resistance comparable to the other components, it is going to cause the total or the combined resistance of the circuit to be lessened, and that would cause an increase in the current flow in the main part of the circuit. So that could affect the voltage reading on the voltmeter. Again, the voltmeter should measure the voltage across the component and not affect the current or the voltage. All right. So if the resistance of the voltmeter is not very high, then it is going to lower the overall resistance in the circuit because of its parallel connection. So that is why. All right, so this question is a circuit using circuit features. We have mixed circuit, so we have in series and in parallel. 2 ohm and 4 ohm here are in series, but they are in parallel with this one. All right, so the reading on ammeter 1, this is here. That would measure the total current. So what we have to do is to find the total resistance really of the circuit. All right. Now, because these are in series, we can add them. So this is 6 ohms combined here. And we can just consider a 6 ohm resistor here in parallel with the 2 ohms. So we have for the resistance, combined resistance in parallel, we have product over sum. Right? So we have 6 times 2 over 6 plus 2. So that's 12 over 8. And that's 1.5 ohms. So the combined resistance of this circuit is 1.5 ohms. And therefore, if the combined resistance is 1.5 and you have 12 volts, and it's 12 over 1.5 for the current, and that's 8 amperes. Right? So you have to analyze the circuit, and you're seeing that there's a branch here. So this means that we have a parallel connection here. But here we have a series, these two are in series. Right? So this one is in parallel to the other two. So we have to work out the series part, and we get 4 plus 2, that's 6. And then we combine it with the 2 ohms, but this is in parallel, not in series. So we have to use the product over sum. Right? So 6 times 2 over 6 plus 2. And that gives us 1.5. And then I is equal to V over the combined resistance, 12 over 1.5, that's 8. Reading an ammeter 2. Now we have what we have here. We have the current flowing here will be different because we now have this resistor to contend with, not the other two. Right, so the current here will be equal to V over R. So 12 over 2. That's 6 amperes. Any questions so far?
No, sir.
All right. All right. This one is about Newton's laws. Newton's 3 laws are to be stated. I trust persons are well knowledgeable of these laws. So there are different ways in which these can be stated, but make sure you do not add in your own words that might give a different meaning for the law, right? So you have different ways in which they can be stated, but don't put anything new in it if it will change the meaning. So basically, law 1 is about inertia, and it is telling you that a body that is at rest will stay at rest, or if it is moving with constant velocity, then it will do so unless an unbalanced force acts on it. So once a body is moving with constant velocity, or if it is at rest, it means that there is no unbalanced force acting on it. Law 2 now is a continuation of law 1, which is telling you that if there's an unbalanced force, then it will cause the body to undergo a change in momentum, right? And how fast that change in momentum takes place will be proportional to the applied force. That's the resultant force. And it's going to take place in that same direction. Law 3 tells us that forces do not occur singly, in pairs. So if a force is applied on an object by a body, the second body will exert an equal force on the first body, but in the opposite direction. So equal magnitude, but opposite in direction. All right, this one is about momentum. Now, momentum is equal to the product of mass and velocity. So the mass of the test dummy is 70 kilograms, and the car is traveling at 26 meters per second. So 70 times 26, that's 1820 meters per second. Average force exerted on the dummy by the seat belt. Now, force is equal to, we can use change in momentum over time. All right. Rate of change of momentum can give us the force because we know that force is equal to mass times acceleration, and mass times acceleration is the same as the rate of change of momentum. So we calculate the change in momentum over time, and that gives us the force of 18,200 newtons. In this question, we are to calculate the time, the duration of the collision, and we just apply the same equation. Force is equal to rate of change of momentum. So what we do is to substitute for the time, or not substitute, but transpose for the time. All right, so we have that the time will be equal to the change in momentum over the force, and that is going to give us 0.04 seconds. Right, so the force was given 45,000 newtons. Right, so all you need to do is to manipulate this equation or this formula here. All right, this question is about the gas laws, and it's asking about how the temperature, the volume against temperature graph that is used to establish the Kelvin scale. All right, so volume against temperature graph of a gas. We are finding, if we are plotting the temperature in Celsius, we're gonna get a graph that doesn't start at 0, as in 0 volume. So the volume of a gas will not reach 0. Right? So we have this straight line for temperatures above 0 degrees Celsius, or from 0 upwards. Now, how is the graph used to establish its Kelvin scale? The graph is extrapolated, right, backwards, and what is found is that the graph cuts the temperature axis at -273 degrees Celsius. And if we call this temperature the absolute temperature, then what we find is that the relationship between the volume and the temperature will be a directly proportional one. In the case of the Celsius temperature, it is not directly proportional, right? Because when the temperature is 0, the volume of the gas is not 0. But if we allow this temperature to be the new 0, or the absolute 0, then we find that the volume of the gas should go to 0 at this temperature, even though it doesn't, but it gives us an idea. So it's a theoretical concept first that is used to establish the Kelvin temperature scale. And even to this day, the temperature of -273 has not been reached in the laboratory. right? So it's a really cold temperature that is very difficult to achieve. So this is actually the absolute temperature, and we assign that 0 Kelvin. Mathematical relationship between the Kelvin and the Celsius temperature scales. So temperature in Kelvins will be equal to Celsius temperature plus 273. Because minus 273 is considered the new 0. Right? So if this is 0, then the 0 would become 273. So that means the temperature in Kelvins is found by adding 273 to the temperature in Celsius. All right, this question is also of gas laws. And we have the temperature and the volume. And you know that we are told that the pressure is kept constant. No, not the pressure. The temperature is kept constant. All right, so if the temperature is kept constant, we apply Boyle's law, which says that pressure times volume, or the product of pressure and volume, is a constant. Right? So P1 times V1 is equal to P2 times V2. And we are to find V2. So V2 will be equal to P1 times V1 divided by P2. So 5 times 50 divided by 1. And that will give us 250 milliliters. And this should be 1 atmosphere, so there's a slight error here. 1 atmosphere should be here instead of 1 milliliter. All right, so Boyle's law, once you know that, or once you summarize Boyle's law into this equation, PV is equal to a constant. All right, you can always expand this to say that P1 times V1 is equal to P2 times V2. Right? So if PV is a constant, then all values of P and its corresponding V values when you find the product should be a constant. So that is why we can say this. Right? Because when P1 changes to P2, V1 will change to V2 so that the constant are in such a way that the products remain the same. That is how the gas behaves. So it's not that we are saying it changes because of what we think, but that's how the gas behaves. All right, this part of the question, it asks us to find the final pressure. The volume is now kept constant, so what we have to do is apply the pressure law, which says that P over T, mathematical form, P over T is a constant. So we know that P1 over T1 is equal to P2 over T2. Right? So if P over T is a constant, then all values of P and the corresponding values of T, when we divide them, we should get a constant. So we are finding P2 transpose of P2. P2 is equal to P1 times T2 over P1. Right? Or sorry, T1. This should be T1. All right, so we have P2, that's what we want to find. P1, 5 atmosphere, times the Kelvin temperature. Now, once you're doing the gas laws, make sure the temperatures are in kelvins. Everything else every other variable can be in their regular units or whatever their units were in the question, but the temperature values must be converted to Kelvin temperature values. So you're going to add the 273 to the temperature in Celsius. Anywhere you see Celsius temperature, you have to add the 273. So we have 5 times the 60 plus 273 divided by the 25 plus 273, and that will give you 5.6 atmosphere. Right. So the pressure, the new pressure is not very different or not much greater than the old pressure, because that was 5. Now this question is a length question, and it says you are to copy the figure and draw the ray as it emerges on the other side of the lens and its relation to the focus. Show the principal axis and the focal length. All right, so we have, this is a concave lens or a diverging lens. What the diverging lens will do is to cause the light ray to spread away in such a way that it appears to be coming from the a point beyond where you're looking, so that virtual point, because the light ray is not actually coming from this point. That's the principal focus or the focal point. Right? So you would draw this ray when it emerges. It's going to be bent away like this. So it's diverging, not converging, but diverging, going spreading away, so that it seems to be coming from here. And where it seems to be coming from is called the principal focus. The principal axis runs through the center of the lens, that an imaginary line. And the focal length is the distance between the principal focus and the lens, and that's the center of the lens, the optical center. So we have uppercase F for the principal focus. That's a point, right? But the focal length is a distance, and that distance is the distance between the principal focus and the optical center, which is on the lens axis that the principal axis runs through, right? Basically the center of the lens. Now the magnification given by a lens, you can use image height over object height, or image distance over object distance. But make sure it's always image over the object. Whatever about the image over whatever about the object. All right. So this is the worded formula or symbols. M is for magnification, I is for the image height, O is for the object height. Or if you want to use B over U, B is the image distance and U is the object distance. Now, since it's just one mark, you just need to put either one. All right, next question is also lens question. So we have a figure where we see an object AB, and they say it is 20 centimeters in front of a converging lens, which has a focal length of 10 centimeters. And the principal focus is seen as a point here. This distance should be 10 centimeters on either side. Now, the object distance is twice that of the focal length. Right? It means that you're going to get an image that is formed at the same distance on the other side. Right? So if you know this, these features, then you can know when your answer is correct, or you can know if your answer is correct. So the object distance is 20 centimeters. Focal length is 10 centimeters, so that's twice the focal length. And for a converging lens, whenever the object is at 2 times the focal length, you will get an equal size image, and that will be twice the size, twice the distance on the other side. So when we use this formula, same lens formula, but we write it in terms of the focal length. And then we transpose for V, we're going to get that V is equal to U times F over U minus F. And so the distance is 20 centimeters. So the object distance and the image distance are the same, but on either side. All right. All right, so what we have now, calculate the magnification. Now, if the image size and the object size are the same, or the distance, what we have here is the distance. Image distance and object distance are the same, then it means the magnification would be 1. All right, magnification will be 1. So dividing V by U, we're gonna get 1, that's times 1 for the magnification. Next part asks if the image is real or virtual. The image is going to be real once it is formed on the opposite side of the lens. It's going to be a real image. All right, this question is about temperature. And we have a table to fill out where we have the first column being the type of thermometer, design feature, and reason for design feature. So we have mercury in glass thermometer. Now the design feature highlighted here is narrow bore. What's the reason for narrow bore? So narrow bore is for greater sensitivity to temperature changes. All right. So when the diameter, the bore is really the internal diameter of the capillary tube. So the narrower the diameter of the capillary tube, the greater sensitivity, meaning the response that the thermometer has to a small change in temperature will be greater. Right? Are there any questions?
No, sir.
Okay, so next one now we see we'd have been given the design feature and the reason for the design. Constriction in the bore. Once you see this, you know that it's a mercury in gas clinical. Right, so this one is clinical thermometer. Thermocouple, and you're given a reason, ability to measure rapidly changing temperature. And once you're given that, you know that it's a small wire junctions, right? Small wire junctions allow rapidly changing temperatures to be measured. Because if they or when the junctions are small, they do not need a lot of heat to be, to be warmed up. So they can be, the temperature will change very easily because they're small. Next question is to define the upper and lower fixed points on the Celsius temperature scale and state their respective values. So upper fixed point is the temperature of steam above water boiling at normal atmospheric pressure. And this is 100 degrees on the Celsius scale. The lower fixed point is the temperature of pure melting ice. And this is designated 0 on the Celsius scale. Now, why you measure the temperature of the steam? This is because any impurities in the water would affect the temperature at which it boils. And you also need to know that the boiling point is taken for normal atmospheric pressure. Right? Boiling points are really dependent on atmospheric pressure. So to avoid the confusion, we use a standard, and that's the sea level temperature, the pressure, sorry, at sea level. So it's 100 degrees at sea level. If you go at higher altitudes, water will actually boil at a lower temperature. Right? On the lower fixed point, you're checking pure melting ice, because again, if there are impurities in the ice, it will cause the temperature to not be the actual temperature. And so we use pure melting ice. All right, for this question, we are finding the temperature in Kelvin, and remember that you just add 273 to the Celsius temperature. So we're going to have 273 added to each of these, and you get your values here. Now, you're asked to find out if the pressure law is supported by this set of data and explain your answer. First, I point out the pressure law here. It says for a fixed mass of gas at constant volume, the pressure is directly proportional to the absolute temperature. Right? So P over T is a constant. So if the ratio of pressure and temperature is constant for any two sets of values that you see in the table, then the data is supported. Right? So what I have done is to use two of the pressure values and the corresponding temperature values, and this will be in Kelvins, not the Celsius. If you use the Celsius, you won't get the valid answer. So first pressure, 1.1 times 10 to the fifth power over 308, and the 1.3 times 10 to the fifth power over 364. Both of these ratios is equal to 357. All right. And so since the ratio is constant, then it means that the pressure law is supported by the data. All right. So you have to remember that the pressure law deals with ratio of pressure to temperature, and that ratio should be a constant. So if you work it out and you get the same values, or if they are really close, then you know that the data is the law is being supported by the data. All right, this one is a lens question again. So describe the object with reference to the focal length of the lens. Describe object distance required to produce each type of image. And for real images, object distance will be greater than the focal length, while for virtual images, the object distance should be less than the focal length. Right? State the orientation of each image. Real images are inverted, while virtual images are erect or upright. You have to remember this. Once it's a real image, or once it's inverted, it's a real image. And once it's erect, it's a virtual image. Complete the ray diagram shown in figure 6. So we have this. This symbol means that it's a diverging lens. And for a diverging lens, it's going to spread the rays away from each other. Now they are going to appear that they are coming from this point, which is the focal point or the principal focus. Next part, calculate the magnification where a lens produces an image height of 3.6 millimeters for an object height of 2.4 millimeters. So we know that the magnification is equal to image height over object height. So that's 3.6 over 2.4, and that's 1 times 1.5. Start. For the same magnification, calculate the image distance given that the object distance is 20. And what we have is that the magnification, you know that the magnification is image distance over the object distance again, and always image over object. So we already know the magnification to be 1.5, and we substitute our values there and transpose for V. So V would be equal to 1.5 times 20, and that's 30 centimeters. Right. Calculate the focal length. All right, so the focal length, we know that the original formula says 1 over F is equal to 1 over U plus 1 over V. And we can just make it a bit simpler and say that F is equal to U times V over U plus V. That's 20 times 30 over 20 plus 30. We're going to have 600 over 50. And that's 12 centimeters. All right. All right, so this goes to continue here.
All right, good evening, everyone. Right, so for this question, we have a circuit diagram that is labeled, and you're asked to represent or to state or give a description of the circuit in the space provided. So on looking at the diagram, one of the first things that you can see is the 3V at the top left of the diagram. And that 3V means 3 volts, and that is the EMF of the battery. And you can see that it is connected in series with an open switch that's next to the battery. And then you have a variable resistor, a fixed resistor, and a meter. All of those are connected in series. And then the voltmeter now is connected in parallel with the fixed resistor. Right, so you should be able to identify or to be able to describe the circuit based on your knowledge of the symbols. So just be careful in the day to study those. Right. So a physics class was given the diagram trigger class. So we can see that we have the EMF of the battery being 12 volts as connected in parallel, a 1 ohm and a 2 ohm resistor in parallel, and then there is a 3 ohm resistor that is in series with that particular arrangement. So you're given the formula to calculate the equivalent resistance of 2 resistors in parallel, and you're asked to calculate the equivalent resistance across BC. So given that R is equal to R1 times R2 divided by R1 plus R2, you just fill in those information. So R1 and R2 would be 1 ohm and 2 ohms respectively. So 1 times 2 is 2, and you divide that by 1 plus 2, which is 3. So 2 divided by 3 is 0.67 ohms. And that would be the effective resistance of the parallel part of the circuit. Then you are asked to calculate the current flowing in the closed circuit, which means that you need the total current. So before you can find the total current, you need to find the total resistance that is in this circuit. Now, having found the parallel part, what you had, that 0.67 ohms basically is saying that you could replace the 1 ohm and 2 ohm resistors with one 0.67 ohm resistor that would be in series with the 3 ohm resistor. So the total resistance then would just be 0.67 plus 3 ohms, which is 3.67 ohms. Now, having the total resistance and knowing the total voltage, which is 12 volts, can use Ohm's law to calculate the current. So 12 divided by 3.67 would give us 3.3 amperes. Right? Now, when the current in part B, number 2 flows, what is the power that's dissipated in the 3 ohm resistor? Right, so there are quite a few formulae that you should know for calculating power as it relates to electricity. Now, since we have the current and we already know the resistance for the 3 ohm resistor, we can simply use the formula P equals I squared times R. So we square the current, 3.3, and then we multiply that by 3. That should give us total power of 33 watts. All right. So sharing my screen now. So we're on to this next question that seeks forces and Newton's laws. We have 2 physical quantities, and we also have some SI units to fill in. You can fill in either the word or the symbol. So quantity being force, the SI unit of force is the Newton. You can write out the word Newton, N-E-W-T-O-N, or you can write the symbol capital N for Newton. Now, linear momentum is the product of an object's mass times its velocity. So the SI unit would be the same thing as the SI unit for both. So that's or kilogram meter per second. You could write this out in words as well. Easier to write the symbol, but either is fine. So you're then asked to state Newton's third law of motion, and in layman's terms, that's the action. Every action equals or gives rise to an equal but opposite reaction. So the formal wording of that law is basically if a body A exerts a force on body B, then body B will exert a force on body A, but this force will be an opposite in action. Okay. If you have any question as we go along. Okay, so of course, if you get a question like this in the exam, you don't necessarily have to draw anything as sophisticated, for a better expression. You don't have to draw anything as sophisticated as this. If it's even a rectangle and you label it plane, the important thing is to on the plane and then use Newton's third law to explain how it is that this would happen. So we see here that the plane is, there are 4 main forces that are acting on the plane. What happens is that the combustion of the fuel in the plane's engines will cause there to be a backward force that's released, basically, and that gives rise to the thrust, which pushes the plane forward. Now, at the same time, there is a downward force that the wings will exert on the plane. That would be an action force, right? And then that downward push that the wings provide will cause the plane to be lifted upwards. So that's the reaction force. So these 4 forces basically balance each other, or the upward and downward force balance each other, and the left and rightward forces balance. Then the plane will be flying in a horizontal motion. Any questions?
No, miss.
All right, wonderful. So continuing with the same question, we're asked to define the term linear momentum. We alluded to this earlier. So it's a quantity of motion of a body that is moving in a straight line, and it is given by the product of the mass of the body and its velocity. All right. Now you're then told that you have an 8-kilogram ball traveling to the east at 10 meters per second, and it collides with a 2-kilogram ball traveling to the west with a velocity of 5 meters per second. And then after the collision, move together, and you're asked to determine the final velocity of the ball, assuming that there are no resistive forces. Now in this case, because we have a collision that takes place and we're assuming that forces or opposing forces or external forces, then we can assume that the law of conservation of momentum would hold in this case, which means therefore that the total momentum of the system before the collision will be equal to the total momentum. Remember, mass times velocity. Before they collide, we would be concerned with the initial velocities. So for the 8-kilogram ball, it would be moving with a velocity of 10 meters per second to the east. So we assign that a positive velocity. And for the 2-kilogram ball, since it is moving to the west, we will assign that negative velocity. Right? So whenever you have use positive and negative to represent the velocities, right? So remember, the velocity is a vector. So if you use positive for the east, then you have to use negative for the west because the directions are. And you could also use negative for the east and positive for the west, but because by sign convention, generally we use positive to the right or eastward and negative to the left here. For the balls they move together. Because they move together, the mass is now, and they both travel the same distance. Right? So all we need to do after the collision, mass is 8 plus 2, and we multiply the mass by the common velocity at which or with which the mass travel. Right? So we work out the momentum before, the total momentum before would be equal to 70 kilometer per second, and we divide them by the combined mass, which was a velocity of 7 meters. So we get a positive velocity. It means that the bodies will move together going towards the east. Okay. That's the end of this particular question. This question has to do with waves, wave characteristics, and the wave equation, and it's specific to electromagnetic radiation. So we have some background information here. Humans can see electromagnetic radiation only between wavelengths of about 4 to 7 times 10 to the minus 7 meters, and this is what we call part of the spectrum. It would consist of the colors orange, yellow, green, blue, yellow, violet, those within that wavelength range. Now, a rattlesnake can detect electromagnetic radiation of frequency 3.5 times 10 to the 14 hertz, and the honeybee can read. Now, we know that wave equation says that wave speed is equal to the frequency frequency of the wave multiplied by the will travel the same speed, all right? So electron speed of the rattle snake, right? The frequency 5 times the meters per second. If we transpose the wave equation to be equal to the speed, the frequency. So we can divide 3 times 10 to the 8 by 3.5 times 10 to the 40. Now, when you're doing these questions with powers, exponents, it's very important for you to remember that you have to use a bracket. Another trick that you can remember, of course, is that when you are multiplying or dividing powers of 10, they have this, then in this case, because we can succeed, right? So you could divide 3 by 3.5 and give you 0.857. You could round that up to 0.9, sorry. And then it would be times 10 to the minus 6. And of course, you can then write your answer in standard form. And that would give you 9 times 10 to the minus standard form, which would be 9 times 10 to the minus 7. A similar thing here, we have the same speed, but now for the honeybee, the frequency is 1 times 10 to the 15. And so we can use three divided by 1, of course, that's where there's for it's now if the lightning strikes, then you use the formula speed is equal to distance started. The distance 750 by the time 2.3 seconds, and that gives us a value of 326 meters per second. Right? And this is pretty close to the accepted value of speed air. It's about 330 to 3 meters per second. All right. So let's discuss electricity. Refer to concave electric current in an electrolyte and then computers both conventional current. Now, electric current in a metal has to do with the flow of free electrons, and these right. So electrons are negatively charged, right? The flow of electrons, of course, would be the flow of negative charges. Now, in the electrolytes, we have a system which will have both anions and cations flowing. Now, anions are negatively charged, cations are positively charged. So we're in metal, you only have negatively charged electrons flowing. Electrolytes, it's ions that flow, and both positive ions and negative ions, which are ions. Because we know conventional current has to do with the flow of charge from positive to negative. Current in a metal runs, electrons will flow in direction to conventional current flow. Now, in an electrolyte, you would have cations that would follow conventional current going from positive, but then you have also had anions now flowing in opposite direction to the flow of charge in conventional current. Okay. Now, based on what we would have stated earlier, you're asked to tell whether or which the two media, whether a metal or an electrolyte, would have a similar current flow in a semiconductor. Okay? Now, in a semiconductor, you should remember or recall that electric current has to do with the movement of electrons which are negatively charged, as well as what we call holes, and holes are positively charged, and this happens in opposite directions. So because of that, it would be more similar to the flow of current in an electrolyte rather than a flow of current in metals. The question says that we have the makers of other cell phone have upgraded the battery capacity from 4,320 coulombs to 9,000 coulombs. Now, the standard charger can be current of 0.6 amperes, and you're asked to find out or to calculate how much more time to charge the battery, whole battery. Okay. Now you can use a Q equals equal times time and work out the time given the charge, right? So we know the new charge and the old charge, and we know the current in each case, right? So with the old battery, the time taken would have been 7,200 seconds based on the charge of 4,320 divided by the current 0.6. Now with the upgraded battery, you have the same current, but now the charge has increased to 9,000 coulombs. So you realize that the time would now be almost doubled. Okay, so to get the difference in time or the difference in charging time, we subtract the two times that we would have calculated. So 15,000 divided by 7,200 is equal to 7,800 seconds or 130 minutes. All right. So now, in order to maintain a competitive edge, the cell phone maker needs to keep the same charging time for the new model as the old model. So now we need to calculate what the current rating needs to be for the time to be the same as the old, which is 7,200 seconds. So given that the charge is now 9,000 coulombs for the new battery, and we want the time to be 7,200 seconds, means that the cell phone makers would need to upgrade the current rating on the charger to 1.25 amperes. Right, so as equal to Q upon T. Right. Okay, so now we have a question on cells. So we have one here, and you have two sections that you would be required to label. So here in the center core, basically we have the carbon or the graphite rod is a link here we would have the ammonium, chloride paste. Now we're being told that the zinc carbon cell is a primary cell, and then the lead acid cell is a secondary cell. You have to state three differences between the primary and secondary cell. And we have brought for you. So we know that the primary cell has a smaller EMF. Of course, that's a relatively small EMF compared with that of secondary cell, which is about 2.0 volts compared with 1.5 volts for the primary. Now, for the primary cell, the EMF will decrease over time, but for the secondary cell, that EMF will remain fairly constant as it discharges normally. Okay. Now, one of the main differences between the primary and secondary cell is that the primary cell is not rechargeable. So once it's finished, it's just finished, and you have to discard it and change the batteries or change the cell if it's one. However, the secondary cell can be recharged, meaning that it has multiple life cycles. Now, primary cells are also smaller and lightweight, which makes them more portable than secondary cells, which are typically larger, bulkier, and not very portable as a result. Light is the ammonium chloride paste, and we call this the dry cell, right here. Whereas in the lead acid cell, then the electrolyte is the acid, right? That's sulfuric acid and sweat. All right. Now, a power source or solar module is used to charge a 12-volt battery, and you're told that during one phase of the charging, there's a current to time relationship. We need to ensure that the charge is in order for the charge to be in coulombs, the time needs to be in seconds, right? Sorry. Yeah. Give me one moment, please. So all right, so the charge, once you want to get the charge in coulombs, so if that must be the case, then the current must be in amperes, and the time most notably needs to be in seconds. So we know that the time is 4 hours, so we have to change that 4 hours to seconds by multiplying by 3,600 or multiplying by 60 times 60. Okay? So 1 ampere multiplied by 4 times 3,600 coulombs. Okay? You're then asked to calculate the energy in kilojoules that have been added to the battery. Now we know that the relationship between voltage, energy, and charge is given by E equals Q times V. So we can calculate the energy by multiplying the charge and the voltage. So remember the voltage is 12 volts. So we multiply that charge by the voltage, and then we convert the joules to kilojoules by dividing by 1,000. So that would be 172,800 joules, which gives us 172.8 kilojoules. So just with a reason and value for the voltage of the solar module during battery charging. Now, given that the battery has an EMF of 12 volts, we need to ensure that the charging voltage is larger than that EMF so that it is able to supply current at a sufficient rate in order to charge the battery, taking into consideration the fact that you will have internal resistance. So if the charging source has an EMF that is too low, then the battery is not going to charge, right? So 13 volts to 15 volts should be sufficient. All right, so here we have a typical layout of Rutherford's experiment used to determine the composition of the atom. And if you recognize this, it should be from the Geiger-Marsden experiment, which was conducted to basically disprove the plum pudding model. And so you're asked to label the components A, B, and C. So here A, gold, and B right here would be the fluorescent screen. And then at C would be the radioactive source or the source of the particles. Right. Now, using it from the first experiment, explain why it was critically important for you to use the substance or element component labeled A. We identified that A would be the gold foil, right? All right. Remember that gold is a relatively heavy metal, so it has a large or relatively large mass number. So because of this, it means that the atoms that are present in the gold foil are able to withstand bombardment of the fast moving particles. They should also then be able to produce scattering. So material is also made thin so that the So we're now to state two conclusions from the first experiment about the model of the atom. So two conclusions that we can draw is that the atom has a dense central core, which we call the nucleus, and it is very small in comparison with the rest of the atom. Now, another thing that we could state is that the nucleus is positively charged, being that had deflection, right? So some of the particles would have encountered the positively charged neutrons, and they positively charged neutrons in the nucleus, not the neutrons, the positively charged protons in the nucleus, and they would have the repel and that as a result of the fact that most of the parts were fired at the goal foil actually passed straight through without any form of deviation. Okay. Now this is at mass number 14 for the atomic number represents an atom of the metal silicon. Now we have to determine the number of neutrons found in one atom of silicon. Neutrons found by subtracting these atomic number the number of both protons and neutrons. So we subtract these, then we get the number of neutrons. So 14 from 28 is 14. Now using the same standard notation, state the isotope of silicon 28. As long as you have the same atom, then the is 14, and the mass number slightly. Either increase the mass by 1 or 2, you can also decrease the mass.
Okay, so all right. We have this part of the question which deals with an alpha decay. So we see where an element X goes to an element Y, and also we have helium being produced. So we know that the helium nucleus is the alpha particle. So this is an alpha decay. Next part of the question, we're to determine the values of P and Q. And in a nuclear reaction, we have that the mass and the charge are conserved. So the total mass should remain the same on both sides. So if we have 222 on the reactant side, we should get a total of 222 on the product side. So P plus 4 should be equal to 222. Therefore, P should be equal to 218. And for the charge, Q plus 2 should be equal to 76. So that means Q is equal to 74. Next part of the question, if the element Y then undergoes a beta decay to form an element Z. What is the nuclear reaction there? So beta decay involves the emission of a fast-moving electron, which is called a beta particle. The electron has a mass of 0 and a charge of -1, relative charge and mass. So we have 218 as the mass number for Y, and therefore Z should have a mass number of 218 as well, because the mass of the electron is going to be 0. And for the charge on Z, they should be 1 greater than 74, because the charge on the electron is -1. So when we add 75 and -1, we should get 74. So Z should be 218, 75 mass and charge respectively. All right, next part of the question says, how does radioactive decay affect a particle's mass? Now, the mass of the particle depends on what type of decay occurs. So if there is an alpha decay, then the particle's mass will decrease, while if there is a beta or a gamma decay, there will be no mass change. All right, for this question, it deals with waves. Now it says to distinguish between a transverse and a longitudinal wave, or distinguish between transverse and longitudinal waves. And we know that transverse means at right angles. So transverse waves, the motion of the medium or the particles is in a direction perpendicular to the direction of the transfer of the wave, or the direction in which the wave is traveling. Whereas in a longitudinal wave, the motion of the particles or the medium is in line with or parallel, right, to the direction of travel of the wave. Next question, state one example of each of transverse and longitudinal waves. We have water waves and electromagnetic waves as transverse waves, while for longitudinal waves, we have sound waves and seismic P waves. Those are some earthquake waves. Some of them are longitudinal, so the P waves are longitudinal. And pressure waves are also longitudinal. So anyone, we give more than one here, but anyone, because only 2 marks, so we need just 1 for each. Next part of the question. In the wave equation, velocity, frequency, and wavelength are related. Write the equation. You know that velocity is equal to the product of the frequency and the wavelength. So V is equal to F times lambda. And apply this equation now to part 4. We have 10 hertz and 250 meters. So the velocity of this wave would be 2,500 meters per second. All right, this question now requires us to identify, well, to find the amplitude of the wave first. Amplitude is the maximum displacement from the rest position. So we have indicated the amplitude here between the horizontal axis and where the maximum part of the wave goes on the vertical axis because that is where the displacement is shown. So we have 0.5 millimeters here, but we have to convert that to meters. So we divide by 1,000 and we get 5 times 10 to the minus 4 meter. Period of the wave in seconds. So the period is equal to the period is the time taken for one complete oscillation or vibration of the wave. So we start at the 0, goes to a maximum displacement, come back to the rest position, to the maximum displacement in the opposite direction, and then back to the rest position. That would be one cycle or one complete oscillation. So that's 4 milliseconds. And so we have to divide by 1,000 to get it in seconds. So 4 divided by 1,000, that's 0.004. Or 4 times 10 to the negative 3 seconds. Frequency. Now the frequency is the reciprocal of the period. And therefore, if we find the reciprocal of 4 times 10 to the minus 3, we'll get the frequency to be 250 Hertz. One property of an electromagnetic wave. And we have several properties listed here. Anyone will do. All you have to remember is that electromagnetic waves, they can travel in a vacuum. And they all travel at the speed of light, which is 3 times 10 to the 8 meters per second. They are transverse waves. This question is a radioactivity question again. What is meant by the term nuclear fission? Now, nuclear fission is splitting, and when you see nuclear fission, it's splitting of the nucleus. So usually we have a relatively large nucleus splitting into smaller ones, and of course these smaller ones might be more stable. Now, nuclear energy has advantages and disadvantages as anything else. So 2 advantages. Now, it's a pretty efficient process in terms of mass to energy ratio. So a small amount of nuclear fuel can produce a very large amount of energy compared to fossil fuels. Right? Now, nuclear energy does not produce any smoke or any greenhouse gases because nothing is being burnt really. And the fuel is the fuel of fusion, if we're thinking of fusion, would be very much available and practically limitless. Right? So that would be for fusion specifically. All right. Workers in nuclear power plants need to be extra careful So what are some of those precautions? They need to wear proper protective gear. They need to wear, for example, certain types of gloves when they're handling the nuclear material. They should not handle them directly though. They should use maybe forceps or robotic arms if they are handling it. And they usually have a badge to indicate the amount of radiation that they're exposed to, so that if they are exposed to um, the, if they're exposed to too much, they will be aware by judging from the badge, because it can indicate the levels that they were exposed to. Two advantages of using nuclear reactors. Now, nuclear energy is not so much that it's a pretty technical process or procedure to carry out, and it's very expensive to actually build those nuclear reactors and purchase the fuel. They're not cheap. Accidents can happen in a nuclear power plant, and that can cause tremendous damage because of the energy that is released from these reactions. Also, we have the danger of the radioactive material being exposed in the environment. Now, some countries may not be able to access the fuels, so this may be a disadvantage for some countries in terms of not being able to purchase those materials. Nuclear power plants, as all power plants, they have limited lives, but to dismantle them comes at a great cost. Right. In this question, we have nuclear reaction where uranium-238 is bombarded by a neutron to produce barium and krypton. And also, 3 neutrons are released. Right. State the value of P. So P here would be the charge on the barium nuclei or nucleus. And we know that charge is conserved in the reaction. So what we need to do is to look at the charge on the reactant side. 92 plus 0, that's 92. And we have 36 and 0, 36. So 36 plus P should give us 92. And therefore, P is equal to 56. All right, state the meaning of C in Einstein equation. Delta E is equal to delta MC squared. C here refers to the speed of light, right? Speed of light. And that's 3.0 times 10 to the 8 meters per second. So calculate the total mass of the elements formed after the reaction. The total mass, we add all of the masses for the products. These were given in the table. So the products barium, krypton, and 3 neutrons. So we have to multiply the mass of the neutron by 3. And then add that to the mass of the barium and the krypton. And get 390.190 times 10 to the minus 27. Notice that we do not round off the values. Calculate energy release. Now this requires us to apply Einstein's equation. We have to find the change in mass. So mass of the products minus mass of the reactants. And so we're going to have this change in mass 0.83 times 10 to the minus 27 kilograms. Put that into the equation. That by the square of the speed of light. So we have 8.85 times 10 to the minus 10 joules. Next part of the question. State one use of energy released from the reaction. So this energy that is released may be used to heat water to produce steam, which is then used to drive a turbine of a generator which produces electricity. This question applies to Newton's laws. You are to name and state the law which applies. The carriage is moving horizontally at a constant speed in a straight line. So we know that constant speed in a straight line, that's constant velocity. So Newton's first law applies there. And so you state you write the statement for Newton's first law. Carriage is in free fall. In free fall, a body is accelerating. And so we apply Newton's second law here. And we state the law. Calculate the length of time that the carriage in part 2 is allowed to free fall if it reaches a speed of 64.8 kilometers per hour from this. So we have to change from kilometers per hour to meters per second. And we can do that by multiplying by 1,000 and then divided by 3,600. So you'll get 18 meters per second. Then we apply the first equation of motion, transpose for t. First equation of motion, v is equal to u plus a times t. And g is the acceleration, will be the gravitational acceleration, which is 10 meters per second squared roughly. And so transposing for t, we get t is equal to 18 minus 0 over 10 plus 1.8 seconds. You notice that we have 5 marks here. This question requires not just application of the standard formula or conversion of your units. So 3 marks. Determine the distance the carriage falls in B1. So if we also use second equation of motion, where the acceleration is uniform, we can apply that. This time we are finding the distance, and the initial velocity is 0. 0 plus 18 times 1.8 over 2, 16.2 meters. This question is a lens question, and you have to use a fully labeled diagram to define the principal focus of a converging lens and a diverging lens. So in a converging lens, a parallel beam will be refracted so that they pass through the principal focus. So we have parallel rays, the lens refract the rays so that they pass through the principal focus. And that is the principal focus, that point on the principal axis through which the rays will pass once they are parallel to the principal axis. And for the diverging lens, parallel rays again, but this time the lens will refract them so that they appear to be coming from a point here, and that point is the principal focus. So again, principal focus, a point on the principal axis from which the rays parallel to the principal axis appears to come. They appear to be coming from there. After the lens bends these rays, parallel rays, and you look at it, they will appear to be coming from here. And that point is the principal focus. All right, an object of height 7.2 centimeters is placed 18 centimeters from a converging lens of focal length 12 centimeters. Determine the image distance. So we apply the lens formula. 1 over u plus 1 over v is equal to 1 over f. So we have to find v. Image distance is v. We know that 1 over v is equal to 1 over f minus 1 over u. So that works out to 1 over 36. 1 over v is 1 over 36. So v is equal to 36 centimeters. Magnification is v over u. Image distance over object distance. So it's 36 that we calculated in the first part, divided by the object distance, which is 18. So the magnification is times 2. Height of the image, we know that magnification is also equal to image height over object height. And so image height will be equal to the object height multiplied by the magnification. 7.2 times 2, we get 14.4. State whether the image is real or virtual. Image is real. So look at the question. The focal length of the lens is 12 centimeters. The object was placed 18 centimeters from the lens. So as long as it's placed greater than 12 centimeters, but not equal to 2 times the 12 centimeters. Right? Sorry, once the object is not placed less than 12 centimeters, right, the image will be virtual, will be real. If it was placed less than 12 centimeters to the lens, then it would be virtual. All right, this question applies to nuclear energy again, and it speaks of a real situation in 2011. There was a meltdown of a nuclear facility in Japan. Now, what are two arguments for the utilization of nuclear energy or nuclear fission? And again, large amounts of energy can be obtained from small amounts of nuclear material. So these plants or these reactors are more energy efficient than other types of power plants. You have a relatively large reserve of nuclear materials. So we can have this type of energy being harnessed for a long time in the future. And arguments against heavy doses of radiation, very dangerous, can kill living things or can cause severe burns. Workers have to take extreme precautions to avoid being exposed to too much radiation. Accidents can occur in power stations that may cause the release of radioactive material, and of course, this would be also very dangerous because we're going to have a lot more persons being exposed to the harmful radiation. All right, nuclear fusion, different from fission. In fusion, you have the combination of relatively light nuclei to form heavier ones, the release of energy as well. However, this one is cleaner, and the fuel that will be used will be inexpensive and quite abundant. They usually use hydrogen in the form of deuterium and tritium. And so when they combine those, what they get will be like helium, which is not harmful at all. We're thinking of the abundance and the cost of the material. We're also thinking of the products, right? Products of the fusion would not be harmful, as in are compared to the products of nuclear fission, some of which are even radioactive, like cobalt-60, which release gamma radiation. Right? So that's for fission. You won't have any such radioactive material being produced in fusion. So fusion is basically a much more cleaner or a cleaner type of nuclear reaction. Although it is not quite in operation of any commercial value, but theoretically it promises to be a very clean source of energy. You also have no risk of nuclear meltdown in a fusion reactor, because if anything goes wrong, then the plasma will cool very fast. And once the plasma cools, the fusion reaction cannot take place. So there is no chance of a chain reaction. Whereas in the fission process, if you have the neutrons being released and not being captured, then they can cause a chain reaction. Right? So we have the fusion reaction here where deuterium is combined to give you an unknown plus hydrogen, normal hydrogen. All of this is hydrogen. Notice we have a charge of 1, meaning so 1 proton, hydrogen, everything is hydrogen. And what we do, we have to maintain the charge. So 1 plus 1 is 2. And therefore, whatever is found here should have a charge of 1, because this one has a charge of 1. So we're going to still get hydrogen, but this time it has a mass of 3. Right? So we have tritium. The mass number is 3, but it's still hydrogen, isotope of hydrogen. All right, so we have 3 plus 1 here to give us 4. 2 plus 2 over here is 4. So we have mass conserved and charge conserved. So that is how the nuclear reaction balances. Now, this reaction, they say it's commonly used where deuterium and tritium combines to give you helium plus a neutron. They want us to calculate energy release from such a reaction. Again, we apply Einstein's equation. Delta E, change in energy, is equal to change in mass, and speed of light squared. We work out the change in mass in terms of atomic mass unit. That is what you are given in the table. Atomic mass units is U. So we work out the change in mass in atomic mass units first. We do not round off anything, because if we do, we're going to get the difference to be 0. So if you round this off to 2 and round this off to 3, you're going to get 5. Round this off to 4, round this off to 1, you're going to get 5. 5 minus 5 is 0. Right, so when you're calculating change in mass in a nuclear reaction is very, very small, extremely small in fact. So that is why we cannot afford to round off. So you work out the change in mass in atomic mass units because we are given that as the data. Then we convert that change to kilograms. So we multiply by the atomic mass unit constant here, which is 1.66 27 kilograms. And then we get 3.14 times 10 to the minus 29 kilograms as the change in mass. Extremely small change in mass. So this is for just one nucleus ring. Not a mole or anything. Just one of this plus one of this, one deuterium, one tritium, one helium, and one neutron. So singular, no moles. One single atom of each combined. We get a very small amount of energy. So if you imagine multiplying this by 1 mole, how much energy you get? Very large amount. So this might look really small, but if you were to think of 1 mole of the reactants, then it will be a very large amount of energy. This question is a lens question, and it shows how a homemade projector can be made by using your phone and a magnifying glass. Now, we're asked to find or to suggest the distance that the phone must be placed to get a magnified image on the screen. So since the focal length of the magnifying glass is 15 centimeters, then we do not wish to put it at 15. Because if we put it at 15, we would not get any image at all, because we get parallel rays, and parallel rays will not meet. So we want to put it further than 15, but less than 30. So maybe about 20. We don't want to put it at 30, because if we put it at 30, we're going to get the same size image as the object. But if we put it less than 30, but greater than 15, we have that magnified image. So objects placed at a distance between f and 2f. So greater than 15, but less than 30. Second part of the question says, if the phone is placed 20 centimeters from the lens, calculate the distance the screen must be placed from the lens in order to obtain a clear image. Apply the lens formula again. 1 over u plus 1 over v is equal to 1 over f. And what we want to find is the distance from the screen. So we want to find the image distance, which is v. So 1 over v, based on the equation, is going to be equal to 1 over 60. So that means v must be equal to 60 centimeters. So the screen should be placed 60 centimeters from the magnifying glass. Get a clear image. And the magnification, this phone was placed at 20, the phone is the object. The object distance is 20 centimeters. And the image distance is 60. So image distance over object distance is just magnification of times 3. Part says if the dimensions of the phone screen are 11 times 6 or 11 by 6, calculate the dimensions of the image. Now, since the magnification is times 3, what you calculated here is 3 times 3. It means that the image will also be magnified, both dimensions of the image will be magnified by 3. So 11 times 3, 33, and 6 times 3 is 18. So the image will have a dimensions of 33 by 18 in terms of centimeters. So that's the last question. Correct. Are there any questions? All right, so any questions? Okay, so thank you for participating in the crash course. Hopefully this helps you in preparing for your exam.